Hi dear children, welcome to today's class. Today we are going to discuss exercise 13.5 optional questions in the chapter surface areas and volumes. First question, a copper wire 3 mm in diameter is wound about a cylinder whose length is 12 cm and diameter 10 cm so as to cover the curved surface of the cylinder. Find the length and mass of the wire, assuming the density of copper to be 8.88 gram per centimeter cube. So the given informations are: the diameter of the copper wire is given. Diameter of the copper wire is given, that is equal to 3 mm. Okay, all other informations are given in centimeter. So I am going to convert this into centimeter, that is 3 by 10 centimeter is equal to 0.3 centimeter. Since the diameter of the copper wire is equal to 0.3 centimeter, radius of the copper wire is equal to 0.3 by 2, that is equal to 0.15 centimeter. Now, one cylinder we have in this problem. The dimensions of the cylinder, length is given, that is 12 centimeter. Diameter is given, that is 10 centimeter. Therefore, the radius is 5 centimeter. Now, consider one cylinder. Suppose this is our cylinder and we want to cover this cylinder by using wire. So can you please tell me one round of the wire? I'm going to round this cylinder, wound this cylinder by using wire. Then one round of the wire will cover dash height of the cylinder. Can you please tell me what is the height of the cylinder that can be covered by using one round of a wire? Okay, this is one round of a wire and we need anyway more than one round, second round, third round, fourth round, and we don't know how many rounds we need. First, just tell me how much height we can cover by using one round of a wire. Okay, suppose this is your one round, then this is our wire and this much of height you can cover, right? What is that height actually? That is the diameter of your copper wire. So in one round of the wire will cover 3 mm height of the cylinder. One round of the wire will cover 3 mm. What is that 3 mm? That is the diameter of the copper wire. Okay, 3 mm height of cylinder. Okay, so in one round we can cover 3 mm. Then how many rounds we need? How many rounds we need to cover that entire cylinder? It is given that the total height or length it means height. Okay, total height of the cylinder is 12 centimeter and in one round we can cover 3 mm height. Then how many rounds? How can we find out the total number of rounds? Okay, the number of rounds is equal to, what is number of rounds? Number of rounds is equal to length of the cylinder, length or height. Okay, length of the cylinder divided by diameter of the cylinder, diameter of the copper wire. Okay, length of the cylinder divided by diameter of the copper wire, and that is equal to, length is in centimeter, so the diameter, the centimeter is 0.3. So 12 by 0.3 is equal to 40. So we need total 40 rounds to cover that entire cylinder. Now, then Suppose this is your one round. Okay, that other side is also there. Then can you please tell me the length of the wire required in one round? What is the length of the wire required in one round? Okay, if you consider this portion, the length of the wire required in one round. This is our one round, and the length of the wire required in one round, that is actually is equal to the circumference of the base of the cylinder. Okay, so length of the wire required in one round, the length of the wire required in one round is equal to circumference of the base of the cylinder, circumference of the base of the cylinder. Just look at this portion, and suppose this is our wire and we need to cover this entire cylinder by using this cover, that we are doing it in the form of a circle, right? So the length of the wire required in one round, that is actually is equal to the circumference of the base of the cylinder, circumference of the base of the cylinder, that is equal to, that is of the form circle. So it is 2 pi r is equal to 2 pi into the radius of the cylinder is 5, so 2 pi into 5, that is equal to 10 pi. Okay, so length of the wire required in one round is equal to 10 pi. Total we have 40 rounds. Okay, total we have 40 rounds. So length of the wire required in 40 rounds is equal to 40 into 10 pi is equal to 400 pi. That is equal to 400 into 22 by 7. 400 into 22 by 7. That we will get it as 1257.14 centimeter. 1257.14 centimeter. This is the length of the wire required in 40 rounds, or this is the total length of the wire. Okay, so wire that we are going to consider it as a cylinder. Already the diameter of the wire is given in the question. Now we know the length or the height. Okay, so we got all the dimensions of our wire. Length or height, that is equal to 1257.14, and radius that we already got. What is the radius of the wire? That is 0.15 centimeter. In this question, we need to find out the mass of the copper wire. This mass is actually equal to volume into density. Okay, mass is equal to volume into density. So if we want to find out the mass of the copper wire, we need to find out the volume of the copper wire. Okay, volume of the wire we need to find. That is equal to, since it is of the form cylinder, volume is equal to pi r square h or pi r square L. That is equal to pi into 0.15 all square into 1257.14. 1257.14. This is equal to 88.89 centimeter cube. 88.89 centimeter cube. Now we need to find out the mass. That mass is equal to, mass of the copper wire is equal to volume into density. Okay, density is given in the question, that is 8.88. So volume is 88.89 into 8.88 is equal to 789.41 gram. Okay, 789.41 gram. This is the mass of the copper wire. Now second question, In second question, we have a right triangle whose sides are 3 centimeter and 4 centimeter. It is given in the question other than hypotenuse. Other than hypotenuse is made to revolve about its hypotenuse. Find the volume and the surface area of the double cone so formed. Second question. First we need to consider one a right angled triangle. Okay, this is a right triangle. Now we are going to revolve this right triangle about this hypotenuse. Then this is the portion that will form after revolving this triangle about hypotenuse. So mark it as A, this is B, and let it be A dash, and this is C. Now I am going to take it as D. Now the double cone means in same figure we have two cones. The first cone is A dash. Okay, thus A dash with the diameter A dash is the first cone, and the second cone A dash with the same diameter A dash. That is our second cone. We need to find out the volume and surface area of these two cones. So first we are going to find out the dimensions of this cone. It is given that let it be this AP 3 centimeter and it is 4 centimeter, that is given in the question. Now first we are going to find out the length of BC. Since this triangle is a right triangle, we can use Pythagoras theorem to get the length of BC. So this BC is equal to square root of AB square plus AC square, and that is equal to square root of 3 square plus 4 square. It is equal to square root of 9 plus 16. That we will get it as 5. So the length of BC, that is 5. Now actually I need to get the length of AD. What is this AD? That is the radius of these two cones. AD, that is the radius of these two cones. Next step I am going to find out the length of AD. That we can't find it directly. So I am going to take the area of triangle ABC. Okay, area of triangle ABC. Area of triangle ABC. Since it is right triangle, half BH formula is equal to half into AB into AC. Okay, half into AB into AC. That is half into 3 into 4 is equal to 6 centimeter square. Put it as equation number 1. Okay, 6 centimeter square we will get. Now again I am going to find out the area of triangle ABC. That is equal to half BH. Here I am going to take the base as BC. So half into BC into, then the height is AD. Half into BC into AD. BC length is 5. So 5 by 2 into AD we will get. Put it as equation number 2. What is the speciality of equation number 1 and equation number 2? Actually they are equal. So I can equate equation number 1 and equation number 2. Because both are representing the area of triangle ABC. Then LHS is same, so we can directly equate the RHS. So 5 by 2 AD is equal to 6. Thus implies AD is equal to 12 by 5. AD is equal to 12 by 5 centimeter we will get. Now consider the triangle ADB. Consider the triangle ADB. In triangle ADB, AD now we got, and AB that we know, and BD we can find it by using Pythagoras theorem. So this BD is equal to square root of AB square minus AD square. BD is equal to square root of AB square minus AD square. That is equal to square root of 3 square 9 minus 12 by 5 whole square. That length AD is 12 by 5. 12 by 5 whole square, that is 144 divided by 25. It is equal to, that is equal to square root of 225 minus 144 divided by 25 is equal to square root of 81 by 25. This is equal to 9 by 5. So we got the length of BD, that is 9 by 5. We know the length of BC. Okay, that is 5. Now we need to get the length of DC. What is DC? DC is BC minus BD, right? DC is BC minus BD. DC is 5 minus 9 by 5. Okay, 5 minus 9 by 5, that is equal to 16 by 5 we will get. Okay, 16 by 5 we will get. Now we will consider these two cones. First cone, okay, consider the cone AB, A dash. The radius, that is AD, is equal to, what is the length of AD? That is 12 by 5. Now height, that is equal to BD, and it is equal to 9 by 5. And slant height is equal to AB, and it is equal to 3. Now consider the second cone, AC A dash. Radius AD is equal to 12 by 5. Height BC is equal to 16 by 5. And slant height AC is equal to 4. Now we can find out the volume. Okay. We need to find out the volume of double cone. We need to find out the volume of double cone. This volume of double cone is equal to volume of AB A dash plus volume of AC A dash. Volume of AB A dash plus volume of AC A dash. That is equal to, we know that the volume of a cone is 1 by 3 pi r square h. So that is equal to 1 by 3. On both the equations we will have that 1 by 3 pi r square will be common. So we can take it outside. Okay, we will substitute the value first. 1 by 3 pi into 12 by 5 all square into h. The height of the first cone is 9 by 5 plus 1 by 3 pi into 12 by 5 all square into the height of the second cone is 16 by 5. Just look at this. 1 by 3 pi into 12 by 5 all square is common. Just take it outside. 1 by 3 pi into 12 by 5 all square, we can take it outside. Then what will remain in the first term? 9 by 5 will remain in the first term plus 16 by 5. Okay, and that is equal to 1 by 3 pi 3.14 into 12 by 12 square is 144. 144 divided by 25 into, this is 9 plus 16 is 25. 25 by 5 is 5. And this we will get it as 13.14 centimeter cube. 13.14 centimeter cube. Therefore, the volume of double cone is equal to 13.14 centimeter cube. Now, we are going to find out the surface area. Surface area of the double cone is equal to, that is also the surface area of AB A dash plus surface area of AC A dash, and the surface area is pi RL. So pi into R is 12 by 5 into L of the first one is 3 plus pi into 12 by 5 into L of the second one is 4. And this is equal to pi into 12 by 5 into 3 plus 4 is equal to pi into, okay, pi we can substitute, that is 3.14 into 12 by 5 into 7 is equal to 52.75 centimeter square. So the surface area of the double cone is equal to 52.75 centimeter square. Third question. A cistern internally measuring 150 centimeter into 120 centimeter into 110 centimeter has 129600 centimeter cube of water in it. Porous bricks are placed in the water until the cistern is full to the brim. Each brick absorbs 1 1/17 of its own volume of water. How many bricks can be put in without overflowing the water, each brick being 22.5 centimeter into 7.5 centimeter into 6.5 centimeter. So in this question, the dimensions of the cistern and bricks is given. So first we will find out the volume. Okay, volume of cistern is equal to 150 into 120 into 110. 150 into 120 into 110, and this is equal to 1980000 centimeter cube. If the volume of cistern is equal to this value, then we know that volume of free space. How can we find out the volume of free space? It is given that volume of water in it, volume of water in it, okay, that is equal to 129600 centimeter cube. This much of water we have in the cistern, and the volume of cistern that we got and volume of water also we got. Anyway, these two values are not equal, so it is clear that then we have some free space. Okay, so volume of free space is equal to volume of cistern minus volume of water in it. Okay, that is equal to 1980000 minus 1299600, and this is equal to 1850400 centimeter cube. Put it as equation number 1. The volume of free space is equal to 1850400 centimeter cube. Now we are going to find out the volume of brick. It is given that the dimensions of the brick is equal to volume of a brick is equal to, since the dimensions are 22.5 into 7.5 into 6.5, and it is equal to 1096.875 centimeter cube. Volume of a brick is equal to 1096.875 centimeter cube. And in our question, it is given that volume of water absorbed by one brick. Volume of water absorbed by one brick is equal to 1/17 into volume of a brick. 1/17 into volume of a brick, and this is equal to 1/17 into, what is the volume of a brick? 1096.875. 1096.875 centimeter cube. Okay, this much of water will absorb by a brick. Now, suppose n bricks be needed. Okay, let n bricks, we don't know the number of bricks, let it be n. N bricks be needed. Okay, if we need n bricks, then water absorbed by n bricks, then water absorbed by n bricks is equal to, what will be the amount of water absorbed by n bricks? That will be is equal to n into water absorbed by one brick, right? That is n into 1/17 into 1096.875. Over this we can write it as n/17 into 1096.875. This is equal to equation number 2. Put it as equation number 2. Since the volume of a brick is equal to 1096.875. Okay, volume of a brick is equal to 1096.875. Then what will be the volume of n bricks? What will be the volume of n bricks? The volume of n bricks is equal to n into volume of a brick, right? N into volume of a brick, that is n into 1096.875. The volume of n bricks is equal to n into 1096.875. So now we got the volume of n bricks and the volume of the water absorbed by n bricks. Volume of n bricks. Okay, volume of n bricks or volume occupied by n bricks. Volume occupied by n bricks is equal to volume occupied by n bricks is equal to how much volume can those n bricks absorb? Okay, that is actually is equal to free space plus volume of water absorbed by n bricks. Okay, volume occupied by n bricks is equal to free space plus volume of water absorbed by n bricks. Okay, we have a system. In that system we have 129,600 amount of water. This we need to put some bricks into that system. Then how many bricks we can put into that system, or the volume occupied by n bricks, that is equal to free space. Okay, free space already we calculated, and we have a amount of free space in that system. And if you put one brick into that cistern, it will absorb 1/17 of volume of that brick. Okay, water that will absorb 1/17 of volume of that brick. So we will have that much of free space also. So this total amount of free space, that is equal to the free space already we have plus volume of water absorbed by n bricks. Okay. So volume occupied by n bricks, that is the volume of n bricks. Okay, that is equal to n into 1096.875 is equal to free space. What is that free space? Free space is equal to 1850400 plus volume of water absorbed by n bricks, that is equal to n/17 into 1096.875. Okay, just substituted all the values. Now I am going to take all the terms which contains n into one side, that is n into 1096.875 minus n/17 into 1096.875 is equal to 1850400. Now just look at these two terms. N we have in both the terms. 1096.875 also we have. So that means n into 1096.875 is common in that two terms. So we can take it outside from that two terms. Okay, I will take 1096.875 outside from that two terms. In the first term n will remain. and the second term n by 17 will remain, and this is equal to 1850400. 1850400. Now just take LCM inside this. Then 17n minus n, that is 16n. Just take LCM inside this. Then we will have 16n divided by 17. 16n divided by 17 is equal to 1850400. 1850400. Then what is our 16n divided by 17? That is equal to 1850400 divided by 1096.875. That is n is equal to 1850400 divided by 1096.875 into 17 into 16. After this calculation, we will get n is equal to 1792.4102. Since this n means the number of bricks, that we can write it as 1792 approximately. 1792 bricks we can put into that system. Now, fourth question. In one fortnight of a given month, there was a rainfall of 10 centimeter in a river valley. If the area of a valley is 7280 kilometers square, show that the total rainfall was approximately equivalent to the addition to the normal water of 3 rivers, each 1072 kilometer long, 75 meter wide and 3 meter deep. Okay, this is very simple question. For each river, okay, the dimensions of that river is given. For each river, length is given, that is 1072 kilometer, breadth 75 meter, height 3 meter. Since these two informations are in meter, I am going to convert that length into meter, that is 1072 into 1000. Okay, 1072 in 1000 meter, that is equal to 1072,000. 1072,000 meter. Now volume is equal to LBH is equal to 1072,000 into 75 into 3. This is equal to 2412,000 meter cube. Okay. Now, volume of normal water in 3 rivers. This is the volume of one river. Then volume of water, in 3 rivers. Okay, this is the amount of water in one river. Then volume of water in 3 rivers, that is equal to 3 into 2412,000. This is equal to 7236,000 meter cube. Put it as equation number 1. So volume of normal water in 3 rivers is equal to 7236,000. Now area of valley is given in the question. What is that? Area of valley is equal to 7280 kilometer square. 7280 kilometer square. Now, rainfall in the valley. Rainfall in the valley is equal to 10 centimeter. That is also given in the question. Rainfall in the valley is equal to 10 centimeter. That is given in the question. This is in kilometer. So I'm going to convert this 10 centimeter into kilometer. That is 10 by 100 meter. That is equal to 1 by 10 meter. Now this is equal to 1 by 10 into 1000 kilometer. That is equal to 1 by 10,000 kilometer. So the rainfall in the valley is equal to 1 by 10,000 kilometer. Actually, this rainfall in the valley, that is our height. Okay, this is actually is equal to height. Now, what is the relation between area and volume? Volume is equal to area into height. Volume is equal to area into height. So, volume of rainfall, that is equal to area of valley into height, and that is equal to, what is area? 7280 into 1 by 10,000 is equal to 0.7280 kilometer cube. 0.7280 kilometer cube. But the normal water in that 3 rivers is equal to 723600 meter cube. In the equation number 1, the unit is meter, and now we got the information in kilometer cube. So I'm going to convert this kilometer into meter. Kilometer into meter. What we want to do, if we want to convert that kilometer into meter, here we have kilometer cube. So 3 times we need to multiply this value with 1000. That is 7280 into 1000 into 1000 into 1000. Okay, 0.7280 into 1000 we need to multiply it with 3 times. Then the volume of rainfall, that we will get it as this is meter cube, 7280,000 meter cube. Put it as equation number 2. The volume of rainfall we got 7280,000 meter cube. Now just look at equation number 1 and equation number 2. Equation number 1 means the normal water in 3 rivers, and equation number 2 means the volume of rainfall. So we can conclude from equation number 1 and 2, total rainfall is approximately equivalent to the addition of the normal water in 3 rivers. Total rainfall is approximately equivalent to the addition of the normal water in 3 rivers.